Okay, this video is a demonstration of subtracting complex rational expressions, and it really probably comes after my other video on complex rational expressions where I added two complex rational expressions and where I explained a little bit more about what a rational expression was. Remember, I'm saying that rational expressions are really the process to add them or subtract them is the same as adding or subtracting regular fractions. So if you remember how to add and subtract regular fractions, these will be actually pretty easy to do. There's just a couple of little slight differences in there. And let me show you how to do this particular example here. So when I'm adding or subtracting fractions, I have to have the denominators the same, right? So I'm going to actually compare these two denominators and figure out what's how can I make them the same denominator? What could I do? Well, the first thing I need to do is to factor them. And I look at this binomial, and I say what's common between those two numbers is the 5. So let me take out the 5, and I'm left with x plus 2. Okay? Then I'm going to do the same thing with this denominator over here. I look at 4x plus 8 and say, what's common there? Well, the number is 4, isn't it? So I'm going to factor out the 4, and I'm left with, surprise, x plus 2. So now when I look at these two denominators, they're pretty close to the same thing, except that this one has a 5 and this one has a 4. So what can I do to make them the same denominator, or have the same value? Well, I'm going to multiply this side by 4 over 4. Okay? And I'm going to multiply this side by 5 over 5. Now look what happens when I do that. I get 20 times x plus 2, and over here I get 20 times x plus 2. Now my two denominators are exactly the same. So let me clean that up a little bit and write them over the same denominator, 20 times x plus 2, and rewrite what's up in the numerator. I get 4 times x plus 6 minus 5 times x minus 2. Just rewrite what you have up there after you multiplied by the 1. Remember, multiplying by 1 doesn't change the problem, but it does change the form of the problem. Okay? Okay, now that I've done that, I'm going to multiply out this top part and then add and subtract the different terms and see if there's anything that I can factor out here with what's down in the bottom. So I'm just going to rewrite the denominator and multiply this part out. I'm going to get 4x plus 24 minus 5x plus 10. Okay, so let's go ahead and continue up here. 4x minus 5x is a negative x. 24 plus 10 is plus 34 over 20 times x plus 2. Now, is this factorable? No, that's pretty much done. I could probably say 34 minus x, but that really doesn't change it. 20 times x plus 2, none of those factors in the numerator or the denominator are the same. So basically I'm finished. Okay? Now remember what I asked you to do also is to find out what the restrictions are. And the way you find the restriction is to go back to the original problem, set the denominator equal to 0. In this case I'm going to have two different ones, so I'm just going to do this one first. That's going to be 5x is equal to negative 10, x is equal to a negative 2. And I'm going to say that number is restricted. You don't want to put negative 2 here or it makes the denominator equal to 0. Remember, that's restricted. Let's do the same thing with the 4x plus 8. That gives me 4x is equal to negative 8. X again is equal to a, surprise, negative 2. We already said that's restricted. This answer here is my final form. Negative x plus 34 over 20 times x plus 2, and x negative 2 is the restriction in this problem. Okay, I hope that helped. That was kind of quick, but use this particular video in conjunction with the complex rational expressions where I'm doing some addition. Okay, good luck to you.